Okay, good morning. Hello and welcome to scenic Salesville basement area. It's pretty much floody here. I assume it is where you are. We've had so much rain, but it's finally starting to be windy and dry out a little bit. It's such an exotic location, I thought I'd call it out since I'm staring at my wife's sewing room. But besides that, you guys are here for probability and statistics. I hope you guys are doing well. This is the start of video 2. It is one day later. I didn't get to it right after the first video, so I'll get to it here. So I hope you guys remember this stuff. I don't know if you're watching them right in sequence because they'll probably be posted together, but recall that we were talking about normal curves. And so just a little bit of a review about what that is. Normal curves. So a normal curve, it's a frequency curve, right? And so we've got this shape. It's a bell shape where the very center of the curve is the mean. And we're going to call that mean mu. And from that, we get a couple of characteristics. The first one that we looked at yesterday was that you jump a certain amount left and right from the mean. And that amount that you jump, we're going to call the standard deviation. This is like +1 standard deviation. Recall we used a little sigma symbol for standard deviation last time. We're going to continue that. So +2 standard deviations, +3 standard deviations. And the amount that you jump is always the same in either direction. So if you go backwards, it's like -1 standard deviation, -2 standard deviations, and -3 standard deviations. And the mean, this value in the center, can change for every problem and scenario you're talking about. If you're talking about the mean height of males, it might be 5'10", I don't know. If you're talking about the mean weight of males, it might be 185. And the standard deviation can change with every situation, right? In terms of height, it might be plus or minus a couple of inches. In terms of weight, it might be plus or minus 15 pounds. So those values change for every situation, but the percentages do not change. And so that's why you study these things called normal curves, because the percent of values between each of these magic standard deviation jumps always stays the same. And so we looked at that yesterday, or the last time we watched these videos anyway, and it was the 68, 95, 99, 7 rule, called the empirical rule. So we might use that a little bit today, but the question comes up, what happens if it's not exactly one jump left and right? And so that's what we're going to tackle today a little bit, and it's the next topic called z-scores. And so that's the real topic of today's video, to try to understand this term, z-scores. So z-scores are just how many standard deviations away from the mean you are. And so while that sounds maybe not the most clear as a description, I'll at least try to explain it with some examples here. So let me write that down. How many standard deviations away? Oh, sorry, you'll hear the printer in the background there. My son must be printing an ABC Mouse video from the wonderful Buckeye Trail elementary school teachers who have posted zillions and zillions of assignments for him. Anyway, how many standard deviations away from the mean here? And so that's just how many jumps, right? Right, in our small picture up above, we've got each jump between tick marks represents one jump of standard deviations. So that's what these z-scores mean. And so for us, let's look at an example, and I think that'll make that a little bit more straightforward. So let's say you had a mean given to you of 30. And you knew the standard deviation was also given to you, and it was 10. Now, if you're watching these videos back to back, I'm using the exact same example as before to try to make a reference here. But if not, they should stand alone. So the question is going to say, give the z-score for each value, right? So with this data, give the z-score for each value. Right, first question we've had of this type. So how the heck do you do that? So let's see here. I'm going to give you maybe 3 examples to start. We might use this illustrative example a little bit more. So let's say x equals 40 is our first example. And the second one, x equals 50. And the third one, x equals 20. So the question is, how many jumps, how many standard deviation jumps are these numbers from the mean? So without having to draw the picture now, you should be able to get this thing called a z-score. And so maybe I'll put the answers in brackets here. Maybe I'll switch the color just so you can look at them. But essentially what we're trying to do here is get how far away 40 is from 30, right? The first thing you need to know is how far did you go from the mean. So in this case, we went 10 higher. And since 40 is exactly 10 units from 30, that means it is 1 standard deviation. And so in this case, we'd say the z-score is positive 1, right? Meaning that we went one jump up because it's positive. Same thing on the second score, right? The z-score for the number 50 in this scenario. Well, how many times did we have to jump 10 units, right? The standard deviation is 10. How many times did we have to jump that amount from 30, our starting point in the middle, to get to 50? Well, we had to jump 2 times. So the z-score here is plus 2. And of course, any nerdy math teacher would give you an example for both directions, right? So the z-score here for 20, since 20 is less than 30, right? Envision a number line always. Since 20 is on the left-hand side, we had to go backwards 1 set of 10 units, right? Minus 10 here. And the standard deviation is 10, so that means we went backwards 1 z-score. So minus 1 is our z-score answer for this one. Right, same thing as 40 being plus 1 and 50 being plus another z-score. So each time you add 10, each time you add the standard deviation, you've got another z-score jump. So that is the definition of z-score. It literally means how many jumps did you go, right? How many standard deviations? So that said, it begs the question, right? How many times can you do this before you get one that isn't an integer, right? One that's not perfect. Maybe I'll sneak it onto this example because it's the last type of this kind, but let's say you had x equals 45. How is that obviously different? Well, that's different because it's not an even amount of 10, right? But it's still easy enough that you can do in your head, I think, right? What's the z-score for 45? Well, looking at that little number line above that, it looks like you went up one whole set of 10 and then half of a set, right? You went up 5 after that. So this answer is positive 1.5. And after this example, I'll probably start writing only negative signs, and I'll just leave numbers positive like they normally are, right? You don't need these little plus signs here. That's just for me to help myself make a note of it. But in a sense, the real reason I'm writing the plus and minus is so that you get the point. Anytime you have a positive z-score, it means you had a number that was above the mean, right? It was higher than average. And anytime you have a negative z-score, it means it was below the mean, right? A number that was lower than average. Actually, I played around with this. Let me see if I can save this comment in here. I think it's available in the PDF that way. If I can get it to work, I'm not sure how this saves. There we go. So now you should see this comment in the PDF that I save as well. Notice that if you have a positive z-score, that means that the value that you started with, the x value, is above the mean. It's higher than average. And if you had a negative z-score, it's below the average. So I'll save that audio comment there. So I think you'll be able to see that. I'll download this PDF as well and post it for notes. But that said, let's continue on here. So that begs the question. Very easy when they're integers. Not too bad when it was exactly half of a z-score. But what happens when it's not a half and it's like a weird decimal? Of course, you get a formula for the z-scores. Do you miss your teachers? Do you miss the weird, freaky-deaky ways that we make notes and use stupid voices and stuff like that? I'm sure you don't at all. Just kidding. I hope you do. But the formula for z-scores is z equals x minus mu over sigma. And of course, that means take your value and subtract the average, and then divide by the standard deviation. So that means you're going to get whatever it is, the distance from the average, and then divided by standard deviation. You're literally just counting how many standard deviation jumps that is. And for us, I'll make a note here in green, we're always going to round to 2 decimal places. And that'll become obvious when we start to use these goofy charts that we'll use, but we're always going to round these values to 2 decimal places. And it's essentially because we have a chart that has them all for 2 decimal places. But let's look at some examples and see how pretty easy that is. And I'll just call this example continued because we had numbers 1 through 4 up above. Yeah. So I'll just start with number 5, for example. Let's say you had that same stuff. So I'll repeat that in case you're looking at this note. Mu was 30 and sigma was 10. Find the z-score for x equals 45. Right, we just did that one, so let's see what that looks like when you actually calculate it. Well, that just means based off of this formula, you would plug in your work, maybe using orange for the work, and x was 45, right? It's your data value, so 45 minus mean of 30 divided by 10. You should always try to calculate these by doing the entire top first, right? So what is 45 minus 30? And then take that answer and divide. So 15 divided by 10. If you can't, that one's not too bad, 1.5. We just talked about it being positive 1.5. From now on, I'm going to use 2 decimal places, so I'll go ahead and put positive 1.50. And that's our answer. But we already kind of knew that one. It was 1.5 jumps. I just wanted to do the same one so you could see the formula used. It gives you the same answer regardless. Let's try a bit of a more gross one maybe. So example 6, and then I've got maybe one more. So how about for x equals 15? Same data. What's the z-score for x equals 15? So for this one, you would take 15 as your value for x. To find out how far it is from the mean, you would do 15 minus 30. I'm just using this formula at the top. And then divide by sigma, which is still 10. So that is now negative 15 over 10. That negative sign is important because it tells us a couple things. It says that the z-score is negative, which means something later on, but it also means that our data value must have been less than average because we got a negative value. And we can see that that's negative 1.50 because instead of positive 15, it's negative 15. So this is a z-score of 1.50. Sometimes you see z equals on these answers. All right, but we've done enough of them that I think you're getting better. Maybe one more, and then I'll show you the 2 different variants of this type of problem. And so let's say, could you do that for x equals 37, something a little bit more gross? So for x equals 37, what's the z-score for 37? Remember, all of this is just saying how many standard deviation jumps is that from the average. So don't get lost in the math. This literally just says, take the number 37, tell me how far away from the mean of 30 it was. But tell me in terms of how many times you had to jump 10 units. Right? So this answer is not one jump, because if it was, it'd be 40. Right? This number is 37, so it's not quite one whole standard deviation jump. The way you calculate exactly what it is you just take 37 minus 30, divide by 10. Right? Realizing that you're just finding the difference and then dividing by the jump distance. And so this one, again, you can do it in your head because it's just a decimal, but you're more than welcome to use a calculator. It's 0.70. Again, it's positive. And you are done. You're a pro at z-scores. I hope that helps somewhat. I'm sure there's a zillion videos out there on z-scores. I do not proclaim to be the best explainer of statistics. So by all means, YouTube things, right? You guys are in a special time with this coronavirus business. You're more than welcome to get outside instruction. But I will also encourage you that you can look on Classroom. If you didn't watch the previous video, or I forgot to mention it, or the second version that I saved didn't work, but if you click on Classwork tab at the top, notice all of your assignments are here, but also the textbook resources are at the bottom. So don't forget this, right? This section here is for you. This textbook link literally takes you to our textbook. And so please use that to be able to review this content. I'm following the textbook, pseudo following, right? We're kind of in a weird time, so it's not exactly perfect, but chapter 8, the normal distribution, is what we're going through. And so you can find this content along with videos and extra practice problems if you so choose. But back to these notes to get through it, I'd say we're a little more than halfway, so we're pretty close. This will probably be about 30 minutes long, just like the last one. So those are z-score examples. That's the basics of it. How many standard deviation jumps? From that, there are essentially two types of problems. There are what I call the forwards examples and the backwards examples. And I'm going to start on a new page because I think I can fit them all on one more page. So forwards examples. And we'll do maybe two of those, and then we'll do the backwards examples, and I'll call it a day. But if you can do these types, you can do all of the CK12s that are posted. I think you'll be able to handle all the homework problems. So let's start with a different mean and standard deviation, so we're not doing the same every time. Let's say if the mean is 60, say you did a particular survey and whatever the average answer was 60, but the standard deviation is given to you also. And it is 15 this time. Not as nice, right? 10 was really slick because we could just divide in our heads. Of course, your question is going to be basic. It says find the z-score for each value. This is exactly what we just did a second ago. Introducing z-scores, you're always going to start with the easiest way, right? The forward type. So you've seen a couple of these examples. Now, this one is going to require the formula a little bit more. First problem, x equals 80. Second problem, maybe x equals 50. So what are the z-scores for each of those data points? Okay, how far is 80 from 60? You can either jump right to this problem and say it's 20 above, or you can use the formula, right? You could do 80 minus 60 divided by 15. And that is 20 over 15. That's still not too bad, but this is where I kind of just wanted to show you, you're more than welcome to use the calculator in any way, shape, or form. So 20 divided by 15 is going to give you your decimal. Just remember that we're going to use, oh, I just hit plus, so that was slick. Just remember we're going to use 2 decimal places of accuracy. So when this tells us our answer of 1.3 forever, we're going to leave that as 1.33. So I'll go back to notes if I can. And this number is z equals 1.33. Notice it's positive, right? I stopped writing the plus signs, but we know it's positive because it doesn't have a negative sign. Okay, and then this one is 50 minus 60 over 15. Again, use this video to slow it down or go back if you need to, but now it's just a matter of calculating. And same thing, I'll take negative 10 divided by 15. You can do that several ways. I'm just literally going to put in 10 and divide by 15 because I don't see the negative sign. Oh, wait, there it is. Never mind, negative 10 divided by 15. But regardless, you know the answer is negative. So if you can't find the negative sign on the calculator or you're not sure, just do 10 divided by 15. But in this case, notice our decimal is again very long, right? We get negative 0.6s forever. We're going to use this number, but we're going to round it right here, right? 2 decimal places, which means we look at this 6 and round this decimal up. And so we will get an answer of negative 0.67 in the end. So I really hope I'm still recording because I just accidentally touched a button on the side of the computer and it made it glitch. So I apologize if it's not. But that said, we got z equals negative 0.67. So to you in this class now, you look at that number and say, aha, it's negative, meaning whatever score I got must have been lower than average, and it's not even -1, so it's not that far away from the average, right? Remember, 68% of values are within 1 standard deviation jump. So that's a pretty normal value to get, I think. Okay, that is essentially the forwards type. And as you could probably guess, the next one is the backwards type. So let's look at what those look like. Backwards examples. Isn't this fun? I just envision everyone studiously sitting at home in their pajamas, writing these notes down on a little tablet for themselves, asking great questions, realizing that it's a video and that you can't ask questions, but please feel free to send them via remind message or email. and these backwards examples exist. So let's stick with the same stuff, just so that you can see kind of like fluid examples here. Let's say the mean is 60 still, and standard deviation is still 15. Sigma is standard deviation. The backwards type of problems are going to start with the z-scores, right? And you're going to work backwards to find out what values you started with, what x values. So I'm going to word this way. It can be asked lots of different ways, but what values would have given each z-score? Right? How would you have got these z-scores if you would have, say, had the final answer of z equals 1.00? Or in this case down here, maybe I'll give myself a little bit more space. Right? How would have you got the final answer of z equals negative 1.20? And these can be solved a couple of different ways. You can either use the empirical rule and kind of like intuitively see what you should get, or you could go back to the formula. Right? Remember, the formula is z equals x minus mu over sigma. Okay, so for the first question, what x value gives you a z-score of exactly 1? I chose this example because I think you should know the answer right away. Right? If the mean is 60 and the standard deviation is 15, that means a z-score of 1 meant that you went up exactly 15 and got 75. So this answer is x equals 75. You can do it that way. If the z-score is exactly an integer, it's a piece of cake. Right? To show you how you solve that with the formula that you need for the really gross decimals, I want you to see this example knowing the answer already, and we'll verify it. Right? The formula says z equals x minus mu over sigma. Doesn't that sound really statistical? Pause the video at that moment and show your parents what you're doing. It'll sound amazing. Z equals x minus mu over sigma, right? Take the data value minus the mean mu divided by standard deviation sigma, and you'll get the approximate z-score standard deviation jump count. Super nerdy, good stuff. Anyway, so to fill these out, right, I'll use green maybe. This is the z-score here, is right here. And so that actually goes on the left-hand side of this formula. We don't know x. We do know mu is 60, and the standard deviation is 15. So you are solving that green formula for the value x. So those of you algebra nerds are already done, right? You've already worked through it, but essentially every one of these problems is set up like this. If it's a backwards example, you just times by 15. So you end up getting, gosh, this 15 gets multiplied up here, right? And so you get 15 equals x minus 60. Just because 15 times 1 is 15. And then you solve this for x, right? You just add 60 to both sides. So this answer is x equals 75. Again, same answer that we got before, knowing how z-scores work. So feel free to look through that example again if you need to, but that's the easier version when you know the z-scores nice and simple. Let's try the one on the right hand, or I'm sorry, on the bottom there. Let me see if I can maybe separate this page a little bit, because I want to parallel that using the same exact formula for the second example. So not really writing it right below there, but more so off to the side so I can put it on the same page. So in this case, our z value is going to go where z is, so negative 1.20. And you can see this one's a little harder, right? I don't know how to go 1.2 jumps of the number 15, right? In the previous example, we did it really easy. We said, oh, I'll just start with 60. And in my head, I'll just add however many jumps of 15 there are. Since there was one jump of 15, I added 15. But now I've got to subtract, right? This isn't a plus sign, whoops. It's a minus sign because I've got a negative z-score. So first thing you know is that you're going to get a number lower than 60 because you went down 1.2 jumps of 15. But it's some number bigger than 15, right? it's like 15-ish. It's not quite 30 because it's not 2 whole standard deviations. It's probably like 18 or 19, something weird in there, right? And so the way you need to do that is with this formula up on the right-hand side here. So this is still the same setup. Notice you multiply by the bottom. So take 15 over here times 1.20, or times negative 1.20. I don't know what that is, so I got to bring up that calculator. But negative 1.20 times 15 is negative 18. So again, first step, just multiply and get negative 18 right here. Even if your calculator told you positive 18, you should know that you just multiplied a negative number times a positive number. Right? So it should be negative 18 there. And then add 60 to it. Oh my, I'm at the pressure of adding and subtracting numbers on video, so I better just go over here and put plus 60, because it's going to take the previous answer and add it. And of course, it's 42. That makes sense, right? It's lower than 60 like I wanted it to be, because I knew I had a value of a negative z-score. So this answer was 42. I know what you guys are thinking. It's not that you want this video to be over. It's like, how could I possibly check to make sure that answer is correct? Because I am that one kid that always asked in class, how is that sure? How can I verify? Can I go back and plug it into the problem? Of course you can, right? So you could do that all day. Maybe I'll show you on this one, and probably that's the only one. But if you wanted to, you could take 42, right, and do 42 minus 60 over 15. Get negative 18 divided by 15, divide that, and turns out to be negative 1.20, which is what you started with. So you're more than willing to like plug it in, make it a forwards example, like the top of the page, and check it. But that's additional work that you don't have to do. That's just verifying. But it's a good check, especially if you get an odd answer, a weird decimal. And that's about it. So that was where I was going to leave video 2. So I'll try to post both of these videos at the same time. They'll be linked on YouTube, and you're free to email questions that you have. But I would watch both of those. I guess it's no point in telling you at the end of video 2 for you to watch both, since you've already watched them. But understanding both of these videos helps you get probably all of the CK12. So it's not really like video 1 goes with assignment 7 and video 2 goes as assignment 8. It doesn't really work that way. It's kind of understanding it all together. So hopefully you've looked at both of these before you really ask a lot of questions, because maybe some of the questions were answered in the videos. But otherwise, leave comments. It's been wonderful to have this time with you. But I hope you guys are doing well, and I will see you next video.